8.1, solving quadratic equations by completing the square. So before we complete the square, we need to use the square root method, or excuse me, square root property. So square root property, if you have a squared that equals b, then a equals positive negative b. So basically, anytime you take the square root of something, unless it's distance, it's always positive negative. So in order to solve this, we need to get x by itself, and to get x by itself, we do the opposite of the square, which is the square root. So now we have x equals positive negative 7. It's always positive negative 7, or excuse me, positive negative. Alright, next, before we take the square root, because if we take the square root, there is no square root of 2. That does not exist. It's irrational. So before we take the square root, we need to isolate we need to isolate the squared unit. So we divide by 2. So now we have x squared equals 2. And we're going to take the square root to get it by itself. So we have x equals positive negative square root of 2. Alright, moving on. So there's nothing in front of it, there's nothing to the right, so we can go ahead and take the square root. So we have y minus 3 equals positive negative 2. Now to solve for this we need to add 3, but we have two equations. Our first one is y minus 3 equals positive 2, and then y minus 3 equals negative 2. So plus 3, we have y equals 5, and y equals 1. So our solution is an actual set but that's the correct way to put it, but on my test you can just do this. Alright, again, we're going to move on. We don't have anything to the left, we don't have anything to the right, so we're going to take the square root. So we have x plus 2 equals positive negative 5, so we have two equations. X plus 2 equals positive 5, and x plus 2 equals negative 5. So now we just solve for x. And we write it as a solution set as 3 and negative 7. Or 7, negative 7, 3. Any way you want to do it. Now, we do need to check your answers. You do. I haven't yet, because we haven't come across one where it's not going to work, but you do need to check your answers. Just like in Chapter 7, I hate when it does that. Just like in Chapter 7 when we were working with radicals in an equation, we need to check your answers, okay? And I'll start doing that from now on. Alright, so next. Since there's nothing to the left or to the right, we can go ahead and take the square root. So we have 3x minus 17 equals the square root of 28, positive negative. So we have 3x minus 17 equals positive square root of 28. And then we have 3x minus 17 equals negative square root of 28. So we add 17. So we have 3x equals 17 plus the square root of 28, and then divide by 3. So we have x equals 17 plus the square root of 28 over 3. Now we need to simplify if you can. We can simplify the 28, so we can simplify that down into 4 and 7. So we have 17 plus 2 times the square root of 7 over 3. Alright, we're going to do the same thing to the other side. So we have add 17. We have 3x equals 17 minus the square root of 28. So we have divide by 3. X equals 17 minus the square root of 28 over 3. And then we already know the square root of 28 is 2 radical 7. So we have 17 minus 2 radical 7 over 3. Alright, now we can complete the square, because you'll see that comes in handy when we want to complete the square. So it might seem like a lot, but it's not when you actually work it out. So that's supposed to say 4. To complete the square, if the coefficient of x squared is 1, go to step 2. Otherwise, divide both sides of the equation by the coefficient of x squared. Isolate all variables, terms on one side of the equation. So you want to make sure all the variables on the left, and that 1c, the number, you want to move it to the right. Then you take half of b and square it and add the results to both sides. And then you're going to factor. Now, factoring is so easy with this. It's x, whatever half of b was, and then you square everything. Then you use the square root property to solve for x. So, for example 2, if there's nothing in front of here, then you can go ahead and start working. So we want to half b and square it. So b is 6. Always simplify before you square. So we have 3 squared, which is 9. So what we're going to do is we're going to add that 9 to both sides. And then we're going to factor. So your factor is x and whatever half of b was. Now, whatever half of b was after you halved it. So that's 3. So plus 3. Now, if it was negative 3, then it would be minus 3. Then you square it, and we simplify the right to get 1. Now use the square root property. So we have x plus 3 equals positive negative 1. So we have x plus 3 equals 1, and x plus 3 equals negative 1. Solve for x, we get x is negative 2, and x is negative 4. This is something that you don't necessarily always need to check your answers. Just like in chapter 6 where you could get away with it and you'd be okay, this is another example of that. You don't have to check your answers. Usually it's going to be fine. Alright, example 3. So first we want to see if there's anything in front of that squared. There is. So since there is, we need to divide everything by it. So after we divide everything by it, we have x squared plus 7x minus 1/2 equals 0. Now we need to move over c. So the one that doesn't have a variable needs to be moved over. So we have x squared plus 7x equals 1/2. Now we need to take half of half of b and square it. So we have 7 over 2 squared, which is 49 over 4. So we're going to add that to both sides. Now we need to factor the left side. Your factor is always going to be x or y or whatever variable, and then whatever half of b was. So half of b was 7 over 2. You square it, and then we need to simplify the right side. So when we do, we get 29 over 4. Sorry, not 29 over 4. I don't know. I have no idea where I got that from. 51 over 4. It's 51 over 4 because we have times 2 times 2. So we have 2 over 4 plus 49 over 4. Now we take the square root. Remember, when we're square rooting a fraction, it goes to top and bottom. So we have x plus 7 over 2 equals positive negative, the square root of 51 over 2. Okay, when you're left with a square root that doesn't have a perfect square, so like 20, 30, 42, anything like that doesn't have a perfect square, you don't need to separate it. You don't, because you're not going to be able to simplify anything. So we're just going to subtract 7 over 2. So we have x equals negative 7 over 2 plus or minus the square root of 51 over 2. And you see how they have the same denominator? So you're going to write it with the same denominator. So that is negative 7 plus or minus the square root of 51 all over 2. Alright, example 4. So as long as there's nothing in front of the squared, we're good to go. So we're going to move over this 7. So we have y squared plus y equals 7. Now we're going to take half of b and square it. So we have, remember there's a 1 in front of everything, so we have 1 over 2 squared, which is 1 over 4. So we're going to add that to both sides. So now we need a factor, so it's going to be y plus whatever half of b was, which was 1 over 2. So your half of b is always, when you half it, whatever that is, that's what you're going to go put into the factors. Equals, so we have 7 over 1 plus 1/4, so times 4 times 4. So we're left with 28 over 4 plus 1 over 4, which is 29 over 4. Now we need to use the square root property. So we have y plus 1/2 equals the square root of 29 over 2. So since the square root of 29 does not have a perfect square, do not separate it. We're going to subtract 1/2. So we have y equals negative 1 plus or minus the square root of 29 over 2. Since they both have the denominator of 2, you combine it as 1. Alright, now we're going to solve equations, solve quadratics to solve problems. So basically an application with a quadratic in it. When you go to college algebra, you're going to focus on this a lot more. So use the formula a equals p times 1 plus r to the power of t to find the interest rate r if 5,000 compounded annually grows to 5,618 in 2 years. So let's figure out what we have. So it says the interest rate, we need to find it. So r, we don't know. 5,000 compounded annually. So 5,000 is what you start with. That's p. And then you might remember this all the way back in chapter 2. We did something very similar to this. Then the time is 2 years. And then the annual growth, that's a, is 5,618. So now we're going to fill in the formula. So we have a, which is 5,618, equals p, which is 5,000, times 1 plus r, we don't know, to the power of t, which is 2. So we need to solve this. We need to get the parentheses by itself. So we divide by 5,000. So when you simplify that, you can take a 2 out of each because they're both even. So we're left with 2,809 over 2,500 equals 1 plus r. That's all squared. So now we need to use the square root property. So the square root of 2,809 is 53, and the square root of 2,500 is 50. Equals 1 plus r. Remember, that's positive, negative. So now we have two equations. We have positive 53 over 50 equals 1 plus r, and then we have negative 53 over 50 equals 1 plus r. Now we need to subtract 1 to both sides. So we have 53 over 50 minus 1 over 1 equals r, and then same thing here. So we have negative 53 over 50 minus 1 over 1. So we're going to change 1 over 1 to 50. So we have 53 over 50 minus 50 over 50. So we have 3 over 50 equals r. And then we have negative 53 over 50 equals 50, or excuse me, minus 50 over 50. So that leaves us with negative 103 over 50. So when we think of interest rate, when you think of like when you have interest, when you buy a car or a house, it's percentage. So we have to make this a percentage. So 3 divided by 50, that's 6%. Now, the reason why we don't use the negative 103 over 50 because interest rate is never negative. So the interest rate is 6%. Remember, if you have word problem, you have to answer in words.